This disease has destroyed my life.
This disease has destroyed my life. I have TMAU, and no one will help me. Not doctors, not friends, not even my family. I walk into rooms, and you see pure disgust on everyone's face. No coworker has ever liked me because of this. I shower a lot. I burn my skin with products. I change my diet. I've starved myself. Nothing works. Stories like these are far too common amongst people who suffer from the disease trimethylaminuria, also known as TMAU. TMAU is characterized by the body's inability to oxidize the odorous TMA molecule into the non-odorous TMAO molecule. This inability to oxidize TMA is caused by the autosomal recessive inheritance of a non-functional human FMO3 gene. Without this, odorous TMA is released from the body through sweat, urine, and other bodily fluids. The odor of TMA is described by the smell of rotting fish, leading to insurmountable ridicule and suspicions about lack of personal hygiene amongst those affected by TMAU. In reality, no amount of hygiene can ameliorate the smell of TMA, as it is inherently caused by ingesting dietary precursors during meals. While this may lead to the belief that TMAU can be completely controlled by precariously choosing what to eat, the abundance of dietary precursors of TMA found in most foods makes this next to impossible to achieve without risking other serious health complications. Our team has designed 3 biological devices to target TMAU at its source. These devices are the blueprint for enzymes that oxidize TMA within the small intestine. Esperance is a probiotic our team believes could be a valuable therapeutic option for this disease. To get the full story on what it's like to live with TMAU, our team reached out to the community. Through conversations with Karen Krieger of the Monell Chemical Census Center and iGEM supervisor Ariel Linder, they were able to direct us to various TMAU patients and websites such as Mebo.com, a community where people who have rare metabolic diseases communicate with others for emotional support. Various patients from all over the world reached out to our team to share their stories, much like the one we heard at the beginning of this video. An immediate concern we noticed was that the amount of people who suspected that they had TMAU significantly outnumbered the people who have been diagnosed. To better understand the testing process, we reached out to Dr. Timothy Wood, lab director at the Colorado Children's Hospital. Outside of the Colorado Children's Hospital, very few physicians are knowledgeable about this disease, making it nearly impossible for patients to receive the correct tests or diagnosis. In the rare occasion someone is rightfully suspected of having TMAU and ordered a urine test to send to Colorado or another hospital, health insurances don't cover the cost. Circling back to support groups, people would make posts stating that the cost of sending these tests could be as much as $650, which is nearly impossible to pay out of pocket for these people. After thorough research, our team decided that the most streamlined product we could begin working on was a probiotic that expresses an enzyme that could degrade TMA. Following this trajectory, we met with Dr. John Oliver of Z Biotics and Dr. Jake Wintermute of Ginkgo Bioworks to further refine our design process. After researching the genetic origins of TMAU, It was determined that there are 40 out of 300 known SNP alleles currently associated with TMAU. Due to it being unfeasible to genetically engineer the liver cells of a patient to restore FMO3 functionality, we decided that an enzymatic lactase-like solution targeting the small intestine was the most efficient route. From this point, the bacterial FMO3 TMA monooxygenase, or TMM, was selected to be expressed in E. coli, as it is non-reversible and acts on all alleles. R. pomeroy TMM was selected due to the success of the 2014 Betancourt iGEM team with the same enzyme. Furthermore, the roseovarius homologue was also chosen due to its efficiency during modeling tests. The 2023 FSU iGEM team incorporated modeling for the purpose of better understanding our design, guiding build team activities, and informing us on what the next steps of the project should be. This bacterial model enabled the team to predict the results of the in vitro build team experiment. The model resembles the experiment as the TMA and the solution moves into the bacterial cell, which then gets converted into TMAO. The entire process is made possible by reactions such as absorption and oxidation. The physiologically based pharmacokinetic model shows how much we can expect to be absorbed in the human body, both with and without the probiotic. The models were built off data collected from literature. Since each variable is proven by sources, the model's validity is greatly improved. The bacterial model helps us understand the in vitro experiment. This proved helpful by narrowing down the time constraints, as well as by showing which enzymes were most viable, thus saving time and cost in the lab. Because of the model, we were able to select 3 enzymes out of 6 possible choices, as well as take measurements at the time points we expected the reactions to be done. By modeling the reactions inside the human body, we can know how much bacteria is needed in the probiotic, and whether or not we need to make the bacteria more efficient at producing the enzymes. The model showed that in a normal environment, 78.7 milligrams of TMA will be absorbed. The 3 biological devices made by design were inserted into plasmids, or the plasmids serve as vectors for the NEB express competent E. coli. Once transformed, the E. coli now can produce the enzymes necessary to oxidize TMA into TMAO. This resultant E. coli can be packaged into a pill or had as a probiotic drink, treating trimethylaminuria. To confirm that our E. coli continuously produces a TMA oxidizing enzyme throughout its life cycle, the build team utilized our connection to the FSU Biological Department to measure our TMA concentrations using high-performance liquid chromatography, or HPLC. With our Shimadzu Prominence HPLC, a tungsten lamp is used to test the absorbance levels of samples to quantify amounts of a compound. Due to TMA not having good UV absorbance properties, it is typical to bind it with another molecule that offers good readability. 9-fluororenal methoxycarbonyl chloride, or FMOC chloride for short, is what our team used to ensure TMA can be measured with HPLC. To get data from multiple sources, we contacted Dr. Timothy Wood from the Colorado Children's Hospital. Through collaboration with Dr. Wood and the laboratory supervisor Cheryl Peck, we are testing our samples via tandem mass spectrometry. The hospital analyzes real urine samples of real TMAU patients, so this process was efficient and a reliable way to support our findings. We have sent over a full series of 45 samples from this experiment, with controls and at least 2 samples at 0, 2, and 4 hours for E. coli that utilized all 3 samples. We have been unable to reliably measure TMA after multiple attempts. Our efforts to measure TMA are ongoing, and we will report our results at the Jamboree. In order to ensure safety in the laboratory, we had a training session with Dr. R.C. Knowing all the risks associated with laboratories, our biomedical engineering advisor, Dr. R.C., trained us on the basics of laboratory safety. This includes where all the safety equipment is, such as the eye wash station. We were also made to know emergency contacts, the location of the fire alarm, and where all the PPE is to ensure our safety in the lab, as safety is our priority. After this session, we signed a form confirming our clearance to work safely in his laboratory. After this, we were comfortable and able to proceed with lab work. We adhered to always wearing proper PPE in the lab coats, gloves, hot hands, pants, and closed-toed shoes. We safely disposed of all E. coli samples in biohazard trash containers. We stored TMA and acetonitrile in a flammable cabinet. When aliquoting TMA and acetonitrile, these volatile compounds are flammable and vaporize. Working in a fume hood with these compounds mitigated the risks associated with these vapors. When disposing of TMA or anything that encountered it, we sealed these samples in a biohazard bag and alerted the laboratory staff to clear these biohazard trash containers. These were the main steps taken to ensure safety of all of our members working in the lab. To ensure patient safety, it was vital to make sure that their comfort and respect was honored. The human practice team ensured we asked for consent to use quotes, dialogue, and any recorded materials from TMAU patients. We always honored the rights and cares of patients, being sure to demonstrate respect for members of the TMAU community. Many patients we spoke with did not want to be recorded or have their identities known, hence the use of quotes and ensuring those who shared their experiences with us are happy with how the FSU 2023 iGEM team portrays their words and their disease. In collaboration with the FSU College of Medicine's Institute for Pediatric Rare Diseases, the team plans to continue developing their proof of concept to create e-esperance. With unwavering support from academia, industry experts, physicians, and especially TMAU patients, this probiotic has the potential to bring relief and normalcy to those who have long suffered in silence. E-esperance isn't just a cell-based therapeutic, it's a testament to the power of science and collaboration. Leveraging e-commerce, e-esperance will be delivered to TMAU patients. Despite the small customer base, projected revenues with a base price of $10 a week for a treatment is suitable for both e-esperance and a cost-effective solution for TMAU patients. To ensure scalability and profitability, we're establishing partnerships with a probiotic manufacturer, a probiotic supplier, and a distributor. While staying FDA compliant under Article 21 CFR 117, the team plans to run a simple clinical study confirming that e-esperance decreases TMA concentrations in the human body. This study will allow physicians to feel comfortable referring their patients to purchase e-esperance if they have TMAU. With a potential global revenue of over $400 million, e-esperance has a chance to expand and utilize the solutions we have developed, helping other enzyme-related disorders. We aim to inspire hope and to facilitate a creative and innovative environment to solve issues in the healthcare industry utilizing synthetic biology. We envision this company to provide hope and trust to those who need it most, with our main focus on rare diseases that do not gain enough funding for research. Our goal is to bring novel treatments to those that are often forgotten and to make rare diseases treatable through e-esperance.